In this lesson, we will explain the difference between nuclear fission and fusion, identify uses of radioactivity in day-to-day life, and explain pollution effects of radioactive substances. We learned that nuclear reactions involve emission of small particles, namely alpha, beta, and gamma rays, by radioactive isotopes. However, nuclei of some radioisotopes absorb neutrons naturally, splitting it into two or more stable nuclei. When a stable nuclide is bombarded with a fast-moving neutron, the nucleus splits into two nuclides with release of energy. The process is called artificial induced radioactivity. The splitting of heavy unstable nuclei into two or more stable parts after collision with fast-moving neutron is referred to as nuclear fission, while the energy produced is called nuclear energy since it's as a result of nuclear reaction. The following are examples of reactions involving nuclear fission. The following is an example of nuclear fission. If the rate of fission is controlled by limiting the neutrons emitted, the energy can be used for power generation from the heat produced. We have discussed nuclear fission, where nuclides are bombarded with a neutron and breaking down into smaller nuclides. Sometimes at high temperature, small nuclides with low mass numbers combine to form a heavy nucleus with liberation of large amounts of energy. Medium nucleus can be formed by fusion of 4 protons as shown in the equation below. In nuclear fusion reactions, masses of products are always less than those of reactants, same as nuclear fission. The loss of mass is transformed into large amounts of energy. This principle is used in hydrogen bombs explosions. Nuclear fusion takes place in the Sun and stars. In the Sun, hydrogen nuclei fuse at high temperatures to produce helium and huge amount of heat and light energy. Radioactivity has many uses in various fields such as in chemistry, medicine, industry, archaeology, agriculture, energy, and research. Chemistry determines atoms involved in particular chemical reaction, that is, reaction mechanisms of chemical reactions. In medicine, radiations are used in the treatment of cancer and blood disorder. They are also used in diagnosis of activities of particular organs. For example, radioactive iodine used to monitor activities of thyroid glands. Sterilizing surgical instrument using gamma rays to kill bacteria. The following video clips shows how surgical instruments are sterilized using gamma rays.
The term sterile means free of germs and disease agents. Sterilization refers to the process that removes living microorganisms from materials and objects. The goal of product sterilization is to kill all microorganisms and spores. In addition, viruses, prions, infectious proteins, plasmids, and other DNA fragments are destroyed. This makes a sterilized product non-infectious, meaning you cannot catch diseases from it. Steam sterilization. Heating in an autoclave is standard procedure in most hospitals and doctors' offices. You see the sterilizer being loaded with surgery containers holding sterile goods. The containers serve as storage until the next patient treatment. The materials to be sterilized are treated with overpressure for a certain period of time and at a certain temperature. For prion destruction, the materials that are being sterilized should be heated to 134 degrees Celsius for 18 minutes at 3 bars of pressure. The air in the autoclave interior should be completely replaced with saturated water vapor. These sterility conditions are only guaranteed with Category B sterilizers. These create a vacuum inside the sterilizing unit before the sterilization process begins. This means that air is sucked out and replaced by water vapor. This guarantees that the materials being sterilized are surrounded by water vapor on all sides, an important condition for sterilization.
Tracing leaks in gases, water, or oil pipelines. The following animation shows how leaks are traced in underground pipes. Click on the play button to view what happens. Radioactive materials are used to check the thickness of paper, rubber, and metal sheets. The following animation shows how the Guella-Muller tube is used to check the thickness of paper. Click on the play button to observe what happens. Checking absorptions and use of particular element by plants such as fertilizer uptake, monitoring growth in plants and synthesis of food products in plants, preservation of agriculture products such as perishable food materials, exposure of such food to radiation destroys bacteria, fungi, insects, and pests. The following animation shows how the Guella-Muller tube is used to monitor fertilizer uptake in plants. Click the play button. Carbon-14 is used to determine age of plants and fossils remains and tracing biological processes in plants.
Carbon is a critical ingredient for life on Earth. All living things are made up of about 25 has one extra neutron. This has very little effect on the properties. After some amount of time, as long as an organism is alive and eating, it maintains a constant ratio of carbon-14 to regular carbon.
Nuclear reactors generate nuclear energy which can be converted to electricity for domestic and industrial use. This has been used in countries like Korea and Japan. Exposure to high levels of ionizing radiation is harmful to living cells because radiation destroys cells and body organs with high energy associated with it if inhaled or swallowed, for example, X-radiation. Radiation can ionize and fragment the cells, causing genetic mutation, cause cancer of leukemia, etc., for example, gamma rays. Radiations, when allowed to the skin for long period of time, cause skin injury since they destroy germination layer where the new skin cells are produced.